I just recently did a little clip on how you could use aerial views to show students the mathematics that's in our world around you from an aerial viewpoint. So I wanted to show you how you could take a cityscape. You know, you fly over a city and there's so much geometry just from looking down that you see. You could take a picture from Google Earth or a satellite image that you may have and superimpose it, put it on Sketchpad, cut and paste, drag it in, however you want to do it, and then use the mathematics that you were going to teach anyway on top of the picture so that they get a sense of why people and where people are using the mathematics we're talking about. So whenever I fly over a city, I always think about parallel and perpendicular lines because it's just so apparent. If you're looking at this picture, which I believe is a piece of New York somewhere, you can, just from looking at it, it seems that the streets are parallel. There's a lot of parallel, there's a lot of perpendicular. It seems like there's transversal. So we could be introducing those concepts in a much more exciting way rather than the static way that we normally do, which is to just show two parallel lines with transversal. Well, let's actually test some of that out. Let's see what that does for us. So I'm going to do the same thing here, but I'm going to use Sketchpad to help me. So I've got my picture that I've cut and pasted in, and I'm going to get a line, and I'm just going to follow, one of the streets. So here is one of the streets. Well, it appears that there are many streets that are parallel to this line. Let's test it out. Let's actually use some construction to test it out. So I've got this original line here, and I'm going to go get a point and put it on one of my other streets that I think might be parallel. And I am going to, instead of drawing, I'm going to construct a parallel to this particular line. So we're going to construct a parallel through this point to that original line. And it sure does seem to be parallel. And the nice thing is now with Sketchpad, it's very dynamic. I can now move this point. And because of the property, the way it was constructed to always be parallel to this one. So if I moved this original one, the constructed one is going to move and remain parallel no matter what. So let's put this one back the way I wanted it to go. So it appears that this street's parallel, but if I move it down, it also appears that this, which might be what, a railroad street or something, or it looks like a railroad, a train car, especially in New York, it probably is, train. So that's also parallel, and this is parallel. So there seems to be a lot of parallel lines going on here. Well, what about perpendicular? Well, we can do the same thing. Are these streets perpendicular? Let's just test it out. It appears that they are. So let's kind of do the same thing. Put a point on a street that appears perpendicular. Get my original line and construct a perpendicular. And it appears again that this one is perpendicular. And I do want to show you that because that perpendicular was constructed to always be perpendicular to the original, it's going to remain that no matter what I do to the original. And it might help if we maybe made our two constructed lines maybe a different color just to have them stand out, or maybe made them dotted. Why don't we do dash so that they kind of stand out. We know those are the children from that parent. So it sure does seem like the streets have been designed as parallel and perpendicular. Well, then why is that? And the great thing about this is you're working with a real city, and the kids can go, well, gosh, it really does seem that way. Why would they do that? Why would they do that in the city? And then are all the streets parallel and perpendicular? And so we can just do a real quick visual test here. And what does that mean to be perpendicular? And we can introduce the idea of perpendicular of right angles, have them start doing some measurements. They can measure the angle that is created between this when we say it's perpendicular. Let's measure that angle. What does that mean? I picked the wrong things here. Sorry. Oops. What does that mean to be parallel and perpendicular? Let's get an intersection point here. Well, we don't want an intersection because we want to move it. So what does that mean to be parallel? What does that mean to be perpendicular? And then what's this street right here? Notice we have this street that does not seem to be parallel or perpendicular. What is this street? So I can go get my line tool and kind of trace along this street. Whoops, I didn't grab the line tool correctly. And this street what is that? What is that street? What is that doing? What that street seems to be different, and so we can give it a name, a transversal, and we can start identifying what's a transversal doing. Well, it seems to be intersecting. You can go through all the properties that we would normally do with the students, but you're doing it in the context of a real world situation, and then you can lead into lots of other exciting avenues of why. Why would they have that street? And if you had to go from a certain point to another, what would be the fastest way to get there? And introduce, say, then the Pythagorean theorem of, if I wanted to go from this corner, from here to here, I could walk these blocks, go up and left, but maybe I want to go the fastest way or the quickest way, but maybe I'm in a car and I can't go this way because it's a one-way street. So there's lots of exciting mathematical questions that can come out and non-mathematical questions that come out as you're studying the mathematics. You can talk about your angles, your corresponding, how do I know these are parallel, this transversal, what kind of angles does this form? And you can lead into corresponding alternate interior, and how does that affect the city, and why is the city laid out this way, and what are the decisions that have to be made if you're going to be planning to make a city street or put a street in a building. What does that mean? And then you could even go further and start looking at the shapes of the buildings. If you look, they're very geometric. So are most of the buildings rectangular? And if they're not, why not? So just some ideas of how to start making the mathematics a little more engaging by a simple thing of introducing a real world satellite picture, any kind of picture where you can superimpose using Sketchpad the mathematics on top of something real that makes it real to the kids.